I'm Chimela Ariasov, and this is the paper that I reviewed. It was all about the quantum computing and machine learning for Arabic language, sentiment classification in social media. Our project is predictive analytics for text. It's predictive text analytics for sentiment analysis on customer feedback. And those are my credentials and the student email. Move to the next slide. The application domains and the computational problem. The application domains of this project actually is all about sentiment classification in Arabic social media, and it addresses the increasing digital data generated by the Arabic speakers, the Muslims, the Al-Shabaabs, those people you know, the Arabic ones. The computational problem, what the researchers are aiming to solve is to solve the problem of sentiment classification in Arabic social media. Is a challenging task due to the complex grammar of that Arabic language and its variability in expression. You know, the Arabic language is very complex and it varies according to the speakers or to the different personalities who speak it. Then the paper was aiming to efficiently classify the sentiment in large Arabic text dataset, and it utilized the quantum computing and machine learning techniques. And these machine learning techniques were the QSVM, the quantum support vector machine, and the random forest classifier. These techniques were used to overcome the complexities of the Arabic language. Move to the next slide. We talk of the machine learning models used in this project. The QSVM model, and this model utilized the IBM Q account for access to the cloud-based quantum systems and simulators. It implements the move back to the that one. It implements quantum algorithms for sentiment classifications, and it involves processing kernel matrix generation and estimation of the kernel for new data points. It employs Qiskit framework for building quantum circuits. This Qiskit framework is installed using the pip installer. You install it via the terminal. Then after install it, you can be able to use or import that Qiskit framework in your code. And it was used for building quantum circuits and executing experiments and analyzing the results. Then after that, pre-processing involved the scaling, normalization, and principal component analysis. Then the classification utilized since it's QSV, then it had to utilize the SVM for generating separating hyperplanes. Then move to the next slide. Then here we talk of the random forest model that was also used on the side of machine learning. And this utilized the ensemble learning with multiple decision trees to classify sentiments in Arabic text. And it outlined the steps that involved in building decision trees, selecting, splitting criteria, and combining predictions. They provided the equations that detail the entropy and unimpurity measures that are used for splitting criteria and decision trees. The equations that they provided in paper, but I was not able to get them, to copy them and paste them here. The equation of entropy. Yeah. Then we talk of the evaluation metrics. the evaluation metrics that were used in this paper. The accuracy, and this calculated the ratio of correctly predicted instances to the total number of instances in the dataset. Then that's the formula. The formula is the true positive plus the true negative, then divide by the total number of true positive plus true negative and false negatives. Then we talk of the precision, and this calculated the ratio of correctly predicted positive instances to the total number of instances predicted as positive, and that's the formula, is the total positives divided by the total positive plus the false positive. Then we talk of the recall, and this measured the model's ability to identify the relevant features or instances in the dataset. And then the formula, the true positive divided by the true positive plus the false negative. Then we talk the F1 score, and this provides balance. It balances the measure of those performance by considering both the false positive and the false negatives. And that's the formula. The 2 times into the precision to the previous slide. It's the 2 times into the precision times recall, then divide by the precision plus recall, and those metrics, as they provided a comprehensive insight into the accuracy and the effectiveness of the scientific classification of the Arabic traits. Move to the next slide. Then we talk of the strengths and weaknesses of the models. But the models are QSVM and random forest model. Now we start by QSVM, and this model leverages quantum computing to potentially achieve exponential speedups for circuit analysis. It achieves those speedups to be analyzed for a large data set. Then we talk of the strength of the random forest. This is well established. It is flexible and it can handle complex data set. This makes it suitable for segment classification on social media. Then we talk of weaknesses. We start with the weaknesses of the QSVM. The QSVM, it is limited in hardware and software availability, and this hinders the widespread adaptations. Like, it's not the hardware that support that QSVM is limited, and it's difficult to find it, and therefore it has hindered its widespread to be adapted by many people. Then we talk of the hyperparameters in a QSVM. Hyperparameters need careful selection and iterative refinement. Now talk of the weaknesses of the random forest, and the first weakness, it may strive for nonlinear relationships. Remember, data that is nonlinear, that is, it's distributed randomly, not in a queue. Therefore, it may struggle to capture that data and determine the important features in that data. Then the weakness, it may overfit when the data is noisy. Move to the next slide. Here I talk of the weaknesses of the evaluation models. First, the weakness, by the way, start with the strength and precision recall and F1 score. Actually, they provide a comprehensive evaluation of the performance. They capture aspects like the sensitivity and balance between precision and recall. Remember, the F1 does the balance, accuracy, the accuracy does the accuracy. Then the precision and recall, they do the sensitivity. They help us to determine the sensitivity of the class, the data. And then we talk of the weaknesses. The metrics, those metrics can be sensitive to class imbalances, like when the class of a given data is imbalanced, these metrics are sensitive to it and may not fully capture all aspects of the model performance. Particularly in those scenarios where the data is skewed on one side. Yeah. Move to the next slide. Here I talk of the limitations of the quantum computing using the quantum computing. Then the first limitation it's limited availability of the hardware. Like the hardware that supports that quantum algorithm is limited. And I tried running it on my PC, but it failed to work. I tried to implement it, but it failed. It needed to be installed that I didn't have on my PC. Then we talk of the limited availability of the software, even the algorithm. That algorithm of quantum is limited. It's limited because this algorithm, I think it's early. It has just come to the market. Many people have just discovered it. Yeah. Then we talk of the complexity of the quantum algorithms. This algorithm, remember, it's complex when you're implementing it, and it needs high computing power to work on it or supporting it. Then I'll talk of the integration with existing systems. Integrating this quantum and the existing algorithms or systems, it's difficult, therefore it's limited to use. Move to the next slide. Here I will talk of the implementing the random forest classifier in our project. Remember, our project is predictive text analysis, sentiment analysis. That's the code for the classifier, explaining the classifier, how it's implemented. Move to the next slide. From here, we can explain the code from the above implementation. The X train represents the features of the training data. Now the Y train represents the corresponding labels, and X test represents the features of the test data set. And this data set is pre-processed. We start by pre-processing it and formatting before being used to the random forest classifier. Then after, we initialize the labels for the test data. Then after that, we evaluate the performance of the classifiers using the accuracy, precision, recall, and F1 scores. Move to the next slide. Here I talk of the data preparations. The social media data is pre-processed to remove noise, stop words, and unwanted documents, unwanted elements like missing views, all that. And the text data is transformed into numerical representations using the term frequency inverse document frequency. This one transforms the categorical data into numerical representations. Then after that, we build this decision trees. Decision trees are built by initializing them. There are 100 decision trees to train the subset of the data, and the goal. And then after that, we split the data into areas: the training and the test data. And the most common splitting criteria are entropy and gene impurity. Then after that, we combine predictions. Once all the decision trees are built, the algorithm combines their predictions to make the final prediction. The prediction, that classification, whatever. And the most common method for combining predictions is use majority voting, where the class with the most video is selected as the final prediction. I'll stop here. Thank you very much. I'll still remain in the area south. Thank you. Bye.